to solve some quadratic equations by completing the square today, which is basically my favorite way to solve quadratic equations. So what you do is you use it to rewrite a quadratic equation as something you can solve by taking the square root. So you want a trinomial that's a perfect square, like x squared plus 6x plus 9, because that factors into, I'll just do it up here, it actually works for this problem, factors into x plus 3 times x plus 3, or x plus 3 squared. So since it can be written as a perfect square, you can solve it by taking the square root of both sides, and then you just end up with x equals -3 on that one. Let's see if we can figure out how to rewrite x squared plus 4x plus a mystery number c as a perfect square. So I like to draw this out using some algebra tiles, they're called. Got an x by x tile in blue and some 1 by x tiles in green, and their area is labeled there. So if I want this to be a perfect square, geometrically, that means its side lengths need to be the same. So right now it's a rectangle, not a square. So if you remember from doing this in Algebra 2, I'm going to rearrange. So I'm going to take half of my area that's represented by my x by 1 tiles and move it down so that my side lengths are the same, and this is actually forming a perfect square. So if you think about the dimensions that I've got going on right here, like I said, got some 1 by x tiles. So that means the corner that I need to complete to make this a perfect square needs 4 more 1 by 1 tiles. You could think about, instead of counting them 1 by 1, that's a 2 by 2 area. So you could take 2 times 2 and get that you need 4 unit tiles to complete your perfect square. You can also think about, there's a couple ways you could write the trinomial. You could think about it as all the little individual areas, or you could think about it as side length by side length. So the side lengths of that big square are now x by 2, since x plus 2, since I completed it. So C that would complete our perfect square was 4 unit tiles. And then if I wanted to show you how that makes it a perfect square algebraically, I have x squared plus 4x plus 4 for my completed area, which factors into x plus 2 times x plus 2, which is the same thing as x plus 2 squared. This one's a little bit messier because I want to make x squared plus 7x plus c a perfect square trinomial, but 7 doesn't divide evenly by 2. So when I rearrange this area to create a perfect square, I'm going to have some fractions involved. So taking half of my length and rearranging it, half of 7 is 3.5, or actually fractions are kind of going to be nicer on these, so 7 over 2 would work as well. So I split that area in half, rearranged it so that the side lengths are going to be equal, and then it doesn't look like that corner is the same dimensions, but that should be a 3.5 by 3.5 square region. So 3.5 times 3.5, or 7 over 2 times 7 over 2, gets you that C, your number of unit tiles, is 12.25 or 49 over 4 if you're going fractions. So I'm also supposed to write this in factored form, my completed expression. So x squared plus 7x plus 49 over 4. If you think of your side lengths as your square and use them to factor and rewrite it, the square has sides of x plus 3.5. So you can write it as x plus 3.5 squared. Or you could go x plus 7 over 2 squared, which will be easier when we solve the equations. Now that you know how to complete a square, we're going to solve an equation using completing the square. So the first thing I'm going to do here is draw a picture representing my expression. I have x squared minus 6x, so I need this to be a perfect square. If you split that -6x in half, that gives you -3 x's on both sides to make it have the same side lengths. And then if you look at how many unit tiles we need 9. That's actually not what's in our equation right now. So that 5 unit tiles is wrong. So there's a couple ways we could do this. I'm just going to go ahead and subtract that 5 from both sides of my equation, since 5 units does not make it a perfect square. And then I'm going to go ahead and add the 9 units that I need to both sides of my equation. Don't forget to do it to both sides of my equation to keep things balanced and equal. So that's going to give me x squared minus 6x plus 9 equals 4. And then the whole goal was to create this perfect square so I could factor that x squared minus 6x plus 9 into two factors that are the same. If you look at the side lengths of your square, or you think about factoring that, that's an x minus 3 by x minus 3 square. So you can write it as x minus 3 to the second. And then take the square root of both sides. Don't forget your plus or minus, so you'll have x minus 3 equals positive or negative 2. Add 3 to both sides. And then, since those are both real numbers, you can go ahead and add them and subtract them. Simplify all the way here. You get x equals 5 and x equals 1. Alright, so this one's a little different. First off, let me do some rearranging so that my terms that have my variable are on the same side together. And the way this one's different is your coefficient on your x squared term is not equal to 1. And for completing the square to actually work, we've just had a 1x squared. So we're going to make this 1x squared by dividing both sides of our equation by 4. So anytime you have a coefficient on your x squared term that is not equal to 1, go ahead and divide both sides of your equation by that coefficient to make it equal 1. And then I'm going to run through completing the square, just like we've been doing. Yes, it's a little bit of a messy fraction, but we got this. So I've got x squared minus 1/2 x. So I'm going to need to cut that 1/2 x in half. So half of negative 1/2 is going to give me a negative 1/4 x on each side of my square here. I know it's not to scale at all, but let's negative 1/4 x. I labeled it. So if you think about what number of unit tiles it would take to complete the corner, it's a really small number. That's a negative 1/4 by negative 1/4 area there, which gives you a 1/16 for C. So I need to add 1/16 to both sides of my equation and then simplify. So let me get a common denominator here. I could multiply that 5/4 by 4/4. You are going to want to leave these in fraction form. Don't try and turn them into decimals or it's going to get messy later on, because we want exact values, not rounded off values. So I rewrote it as x minus 1/4 squared because it was side length x minus 1/4, and then take the square root of both sides. So this is where you don't want a decimal. I want to rationalize that if I need to, or just leave it in this case as square root of 21/4 because 16 was a perfect square. You can write that as a single fraction, and if you check in the back of your textbook, it probably is written as one, so either of those is fine.